Hello again, my magnificent math students. Today we're going to be talking about graphing proportional relationships and recognizing the graphs of proportional relationships versus non-proportional relationships. So the first thing I want to be able to do is take a look at graphs and decide if they are proportional just by how they look. So here's something that's really important for you to know about proportional relationships. In a graph of proportional relationships, I'm sorry, it's not working with me there, the graph has to pass through the origin. It has to go through 0, 0. So in these two graphs, A is proportional, this one's a yes, because it's going right here through the origin. B is no, that is not proportional because it does not go through the origin. Proportional relationships have to be linear. That means they have to be a straight line, but they also have to go through the origin. So if either one of those things isn't true, then it's not going to be proportional. So taking a look at two other graphs, one of these is proportional and one of them is not. I hope that you can look at these two and determine which one is which. So in this one, graph C, this is no, because of that right there. It does not go through the origin. And D is a yes, because it does go through right through the origin. If I give you a table without a graph, you could certainly graph these, but I do have another hint for this. For proportional relationships, the ratios here are equal. So what I should be able to do here is divide the y by the x, change in y of the change in x, just like we have for slope. So in this one, if I would take the 90 divided by 1, well, that's 90. But here, if I go with the 200 divided by 2, that's 100. I don't even need to bother checking the other two. If these two are not equal, it's not proportional. Now, I realize that when we start throwing in fractions here, this gets a little bit more confusing for some people. I would start with the nice ones then. If I would do that one and that one. 2 divided by 1 is going to be 2. 4 divided by 2 is going to be 2. 1 divided by a half. I know that's got to be a little bit more work. I would have to do 1 times the reciprocal because we don't divide by fractions. 2. And same thing here. Can everyone understand that 1.5 times 2 would be 3? And each one of these, if I would take the x value and multiply it by 2, I would get the y value. Same thing if I took the y and divided it by 2, I would get the x value. So this is 2. So F, this one is yes, this is proportional, and this is no. The tables are really not a big part of today's work, but I did want you to recognize and be able to see what that could look like in terms of those ratios. So we found 3 of these that were proportional. And I want to just dig in just a little bit on what that really means. So in A, that was one of our yes, proportional ones. I want to find the slope of the line. And it's really tempting to say that this slope is 1 because it's going up 1 square and over 1 square, but that's not really my slope. I have to be careful here. It is going through this point right here, and I did go up 1 square and over 1 square, but when I went up this 1 square, that's really going up 10 and over 1. And again, I would go up another 10 and over 1, up 10 and over 1. So my slope is 10 over 1, or just 10. Now, let me erase some of this so it's not so jumbled. The second part says, find the value of y if in the ordered pair when the x is 1 is really what I'm looking at. So right here, when x is 1, the y value is 10. Okay, let's take a look at this second graph. And it's, again, I think kind of a tricky graph, which is why I'm glad that we're talking through this. This is not a slope of 5. A lot of people look at this and they say, oh yeah, it must be going right here through that point. But it's not. It's off by just a bit. So I have to find a place where it does hit in a really nice spot, which is right there. If that's the first place that I can get to, I can still find the slope. This is just saying I am going to go up 30 and I'm going sideways 5. Well, 30 over 5 is 6. That's what my slope is. Now, I want you to also realize what this means in terms of this problem. If the slope is 6, this is talking about the cost for different numbers of pizzas. It costs $30 for 5 pizzas. That means that it's $6 per pizza. That's what slope can also be. It's the rate of change. It's $6 per pizza. When I look at this again, it's, again, a little hard to read, but I hope that you can understand that when I'm looking at the x is 1 right here, do you understand that that really is at 6 for that ordered pair? It would have been hard to know that just by looking at it without doing the slope work first. In letter F, the slope, that's the change in y over the change in x, right? Let's pick nice numbers. Let's go from here to here with my x's and y's. So my slope, the change in y, this is increasing by 2, and the change in x, that's increasing by 1. Now you can do that with the slope formula if you want to. That would be 4 minus 2, this y minus this y, over 2 minus 1, which gives me 2 over 1. Either way is fine, but my slope is really just 2. And then I want to know this ordered pair again when the x is 1. Right here's where the x is 1 and the y value is 2. So what I want you to recognize here, what you notice about this, is that the slope is the same as the y value when the x was 1. Because really, in our equation, that's what the x is getting multiplied by every single time. So here's what I want you to recognize. In a proportional equation, a proportional graph, a proportional relationship, in any of those, here's what I'm looking at. Y equals mx. M is the slope. They also call that the constant of proportionality when we're talking about proportional things. But it's the slope. It's something that we're really good at finding by now. So in this graph over here, if I would follow this down, this would have to be where the 1 is on the x-axis to get this ordered pair. And it's also saying when the x is 1, whatever the slope was, that's the number that goes right there. Sometimes they also call these kind of graphs that are proportional, they call them direct variation. In 7th grade math, they spend some time talking about direct variation. They find the constant of proportionality, and they call that K sometimes because they really haven't talked about slope yet. So they use a K for the constant of proportionality. I don't know why they don't use a C because it's kind of ridiculous, but whatever. But that constant proportionality, the slope, the unit rate, all of those things are the same. So that's the whole basic idea of proportional relationships. What we're actually going to be doing today, I think, is less confusing than that stuff. What I want you to be able to do today is look at graphs for part of your worksheet and decide, first of all, if they are proportional or non-proportional. If they are proportional, we have to find the slope so that we can also write the equation of that line. Now, these first two problems are the first two problems on one side of your worksheet today. So you should already, if you have been in class, you should have this worksheet in theory And I want you to decide, first of all, if this is proportional or non-proportional. This graph clearly does not go through the origin, so this is non-proportional. And I have no doubt that if you were sitting in class right now, you would look at that and you'd say, but Mrs. Kempe, do I have to really write out non-proportional? Can I write NP? Whatever. I don't really care on the practice problems as long as you understand the difference between these two. So non-proportional, if you just want to write NP in your practice problems, I'm okay with that. However, number 2 is proportional. Because it goes through the origin, right there, boom. Now, I need to know the slope, and this has a negative slope, which is not a big deal. We're good with that. Let me just write down what our slope is. I know it's negative. I know to go from this point to the origin, I'm going to go down 1, 2, 3, and I'm going to go sideways, 1, 2, 3, 4. My slope is a negative 3/4. I could continue that if I wanted to. I could go down 1, 2, 3, and then over 4, and that works again because it's linear. It has a constant rate of change. Now that I know what my slope is, the equation I'm going to write is just going to look like this. I just have to put the slope where the m is. So the equation for this is going to be y equals negative 3/4 x. You find the slope, put it in the right spot, done. That's what one whole side of your worksheet looks like. The other side of your worksheet gives you problems that are all proportional. Every single one of them on this side of the worksheet is proportional. So you don't have to answer if it's proportional or non-proportional. What I want to do is I want you to be able to find the slope so you can write the equation. I just wanted to practice that some more. And I want you to notice, if you're looking at the entire worksheet right now, all of the graphs basically look the same, right? They're all going to go through the origin. The difference is how the x-axis and how the y-axis are labeled. So all of the graphs, all of the lines really do look very similar. What I want to look at on number 1, for instance, and again, this is right from your worksheet. If I go from the origin to this point right here, don't say I'm going to go up 1/1. The slope is not 1. I'm going up 7/1. So my slope is 7/1, which is just going to be 7. If my slope is 7, then my equation is going to be y equals 7x. Now, number 2, it's kind of nice. I kind of planned it this way to have these same problems, similar problems right here. The slope for this line to go from the origin to this point right here. By the way, you could go to any of the points. I just go to the first one because it's the smallest numbers possible. I'm going to go up 49 because that's what it says right there. And then I'm going to go sideways 7. And when I simplify that, the slope is also 7, just like in the first graph. So y equals 7x. I liked having these two that gave the exact same answer on both of them. Please don't expect that that's going to happen every single time, but I wanted to make sure that we were looking at how the x-axis and how the y-axis were labeled. So today's practice problems, it's a 2-sided worksheet. And again, you should have that if you were in class. If you are not in class, if you're a flexible e-learner, you don't need to print these out. You can just look at them on your screen. I just thought that it might be helpful if you could possibly have it as a paper copy on this. So one side of the worksheet is deciding if it's proportional or non-proportional, and then if it's proportional, you have to give the equation. On the other side of the worksheet, for the practice problems, they are all proportional, and you have to come up with the equations of those lines. You know that the answer keys are in Schoology, so please make sure you're checking your work. And when you're all done, there is a learning check in Schoology for you. If you need any help, let me know.